Hello, Phi lovers. Welcome to the channel Phi Books. Here we will be learning the basic concepts written in 5 books. The first book I think we should start with is A Brief History of Time from Big Bang to Black Holes by Stephen Hawking. Personally, I loved this book a lot and it's a fun to read. So let's make physics fun. Here are the list of contents in this book. In the beginning, Stephen Hawking gives us a brief understanding of what he is trying to convey to the readers who are reading this book, and he mentions that he would not be using any sort of maths to do so. Good for the one who hate maths. Here he mentions the phases that occurred in his life after getting diagnosed by the ALS or the motor neuron disease. Apart from this, he was a great theoretical physicist in the 20th century. The first chapter, Our Picture of the Universe, starts with a lot of questions, and one of them are that is our Earth flat? There were many arguments going on, and Aristotle gave his arguments in his book on the heavens. First was that why is the shadow on the moon round in shape? If Earth was a flat, then the shadow should be long and elliptical, like an oval. Secondly, if Earth was a flat, the position of North Star, which is directly above the North Pole, should remain the same from all the positions, but it appeared lower in sky when viewed from south than from north. The third argument stated that if Earth would be flat, then we should see a ship coming over the horizons, sail the upper part of the ship, and the hull, the lower part of the ship, coming towards us at the same time. But actually, we don't see that. But we see the sail reaching towards us first, accompanied by the hull. Aristotle believed in geocentric theory, that Earth was the center of the solar system and other planets, including the Sun, would revolve around it. This was elaborated by Thallume into his cosmological model. His model was accepted by the Christian Church, but he has recognized a flaw in his model. In 1514, Nicholas gave us a heliocentric model that Sun was at the center and other planets were revolved around it. But a century later, his model was taken into consideration when two astronomers, Johannes Kepler and Galileo Galilei, took it seriously. Kepler also gave some modification to Nicola's model and suggested that the planets should have been moved in an elliptical path instead of circular, which fitted into the observations very well. Now it was the time for Sir Isaac Newton. Sir Isaac Newton postulated a law of universal gravitation, according to which every body attracts every other body by a force which is directly proportional to the masses and inversely proportional to the square of the distance between them. This was given by the formula mentioned in the book. Newton realized that, according to his theory of gravity, the attractive force would eventually make them fall together at some point. This was true if the universe was finite, but if the universe was infinite, the stars would remain in equilibrium. But we now think that the infinite universe would be in a unstable equilibrium, as there could be some places where there are more stars compared to the others. And the difficulty is that in an infinite static universe there would be stars everywhere, and the night side should be as bright as the day. Or that there could be a possibility that light from distant star would have not reached us yet. Thus, the universe is infinite or finite is still a mystery and deserves a video of its own. An infinite universe or finite universe must have started at a finite time in the past. Aristotle and other Greek philosophers did not like this idea of creation. They believed that the world around it existed and would exist forever. Arguments given by philosopher Kant is that if the universe did not have a beginning, then there would be an infinite period of time before any event, which seems absurd. And if the universe had a beginning, then there would be an infinite period of time before it. So why should it begin at a particular time period of time? In 1929, Edwin Hubble observed that distant galaxies are moving away from us, means that the universe is expanding. Hubble's observation suggested that there was a time called Big Bang when the universe was infinitely small and infinitely dense. There were many theories who tried to solve this problem. But wait, first we will understand what is a theory. A theory is just a model of a universe which must satisfy two requirements. That are, it should describe a large class of observations and must make definite predictions about the future. Often, a new theory is an extension of the previous one, like Einstein's theory of relativity is an extension of Newton's theory of gravity. The goal of science is to provide a single theory that would describe the whole universe. The approach to find the single theory is broken into two parts. First, there are the laws that tells us how the universe changes with time, and that would help us predict how it would look like later. Secondly, what does the initial state of the universe looks like? Today, scientists describe the universe in terms of two theories, the general theory of relativity and the quantum mechanics. General relativity describes the large scale structure of the universe, whereas quantum mechanics deals with the one on the extremely small scale. One of the major endeavors of physics is the search of a new quantum theory of gravity. And here the chapter ends. I tried my best to summarize the chapter, and if you find some points missing, then please let me know in the comments below. Stay tuned for the next chapter and understanding physics, make it